Hello, everyone. I want to go over the Unit 2 study guide that we had for our test that is coming up at the end of this week. So please pay attention. Let me know if you have any questions via email or in class, and we'll go ahead and get started. So our first example is asking us to change the standard form into factored form and to vertex form, and I tell you what method you're going to use for each. So first, we're going to go with part A where it tells us how to factor. So for factoring, we need to do our box, of course, and this is one of our two box methods. When we factor, the way that we start our box is by putting our first term in the box and our last term in the box. From there, we need to look at our combination of our first and last term, that being 12x squared, and figuring out how we could split this up, how we could split this up via multiplication, factor it in order to get our middle term here. So let me do that side work over here. That's going to be 12x squared. Now, x squared can only be broken up one way, that being x times x. So we're not going to focus on that part anymore because that's already resolved. What we still need to do is break up 12 via multiplication so that we can get our middle term here. So let's list out the combinations that multiply into 12. So we have 1 and 12, of course. We have 3 and 4. We have 2 and 6. And those are ones I could think of off the top of my head. So we look at these combinations and see which one of these will add up to 8. And through some experimenting, we notice that 2 and 6 get us 8. However, we're not aiming for 8, we're aiming for negative 8. So we need to apply a negative to both of these. And that still works, because negative 6 times negative 2 still gives us positive 12, but now it allows us to add up to negative 8. So that's going to be negative 2x and negative 6x. Whenever I find the combination that works, I fill in my boxes with those values. And from there, I just factor my box. I see what multiplied in order to give me this box. So x squared can only be broken up to x and x. I'm looking at this row and figuring out, okay, x times something gives me negative 6x. So the only thing I'm missing there is going to be my negative 6. Similarly, I look at this row and this row, and I notice I'm missing a negative 2 here. So that my factored form becomes x minus 2 times x minus 6. I take whatever's on the outside of my factor box, I put into two parentheses, and I call it a day. That is my factored form. I am done with part A. Part B, I also start with a box. But in this case, rather than do first and last terms, I do my first term, that being x squared. But then what I do is I split my x's. Right now I have negative 8x, so I have negative 8, and I want to split them evenly. I'm completing the square. Squares are even on all sides, so I'm trying to make my box even on all sides. So that means I need to split my x's evenly. Half of negative 8 is negative 4. I'm going to split my x's into negative 4x and negative 4x. So I split my x's, but now I need to figure out what's missing here. The way that I do that is by multiplying my two values here and here. So negative 4 times negative 4 gives me positive 16, and I have found the value that I need in order to complete my square. So this is the value that I need. But I only have a 12. So in order for me to get my 16 that I do need to complete the square, is to do plus 4 and minus 4. From there, I am able to add those last terms so that I could get x squared minus 8x plus 16 minus 4. I added these two to get my desired value. So now I can factor this part of my equation. And I don't need to create a new factor box. I already have one. I split this into x and x, minus 4 minus 4. And what I get is x minus 4 squared minus 4. And from there, I'm actually done. All I'm asking is for the vertex form. So I have the form, and so I am done with number 1. So number 1 and number 2 are linked. I have my equation here, x squared minus 8x plus 12. And here I have x squared minus 8x plus 12. So number 1 is actually going to help me to fill in the information for number 2. So I need my vertex for number 2 and x-intercepts for number 2 because it's asked me to graph the function. And I need my 3 key points in order to graph. So for my vertex, I look at my vertex form. So for this one, I'm going to use x minus 4 squared minus 4. And for my x-intercepts, I use my factored form, x minus 2 times x minus 6. Double checking, I make sure I wrote everything correctly. And it seems like I did. So my vertex form is of the form a x minus h squared plus k. And I know that my vertex form, I have to pull my hk values in order to get my vertex. In this case, I have my h and k values being -4 and -4. But when I pull out my h, I always need to do the opposite side. So that vertex form is going to be 4, comma, -4. And that's how I get my vertex. I'm going to graph it like so. Okay? As a matter of fact, let's start color coding this touch. So we'll call this my vertex. My vertex is going to be in red. That's going to be -4, 4, -4. That's going to be my vertex point. For my x-intercepts, I need to do a little bit of work. But the way that I get my x-intercepts from factored form is when I set this equal to 0. So that's going to be, and to test each of these at 0, so that's going to be x minus 2 equals 0, which happens when, that looks like a less than sign, let's make it more clear. X minus 2 equals 0, and that happens when x equals 2. 2 minus 2 equals 0. X minus 6 equals 0. This happens when x equals 6. 6 minus 6 gives me 0. So my two x-intercepts, we'll highlight those in green, are going to be at 2 and at 6. And now that I have my 3 points, I can sketch my graph. It's not perfect. I wish these lines were a little bit straighter, but we get the gist. That is how we get information from my factored form and vertex form in order to make my graph. For number 3, number 3 is asking us to sketch the scenario to find the equation of the form y equals a x minus h squared plus k. Can't forget that a value there. Unfortunately, that was a typo on here. So let's look at the situation. A student kicks a ball across the field. The ball starts on the ground before being launched upward. The ball reaches the maximum height. I'm going to highlight that because that's going to be relevant. Maximum height of 6 feet, then comes back down to the ground 6 feet from where it was first hit. So I have my 2 pieces of information that's going to help me sketch my graph. So I know my maximum height is going to be at 6, and my maximum distance is also going to be at 6. And I know that the path that it's going to take, just by picturing in my head, is that my ball is going to go up in a maximum of 6 feet and then come back down. They're not hard lines, so you don't want this V shape. You're going to want this more curved parabolic shape, especially because we know how to write those equations. So I sketched my graph. However, I also need to find my vertex here because my vertex, the more information I have on my graph, is going to help me make my equation here. So what we're going to do is we're going to try and figure out my vertex, my x and y values for it. So I know my y value, I know I'm 6 feet high. What's a little bit trickier is to figure out what my x value is. However, what we should remember is that if we start at 0 and end in 6, and those are our x-intercept, we know that our vertex is always in the middle of my x-intercept. So halfway between 0 and 6 is going to be 3. So I know my vertex value is going to be 3, 6, which then is going to help me with my equation. If I have the equation y equals ax minus h squared plus k, I could plug in and get me y is equal to a x minus 3 squared plus k. Okay, so I have my vertex in there. The only thing I need to solve for now is my a. And I need to do that by choosing a point from my sketch that I know my graph goes through and plug in for my x and y. I cannot solve for 3 variables at once, so I need to eliminate 2 of them so that I could then solve for my a. So what does that look like? Well, I know my graph goes through 0, 0. So I'm going to take that, 0, comma 0. I'm going to plug in for my x and y value here. So instead of writing y, I'm going to write 0 is equal to a, 0 minus 3 squared, plus, apologies, that shouldn't be a k, because we know what value that's going to be, right? That should now be a 6 plus 6. So now I have my zeros plugged in. I only have an a left over. So now that lets me solve for a. So that's going to give 0 is equal to a. And 0 minus 3 gives me negative 3. Negative 3 squared is going to give me 9. So I'm going to write 9 plus 6. So now I've simplified my parentheses, and now I could actually start solving for my desired variable a. So in order to get a by itself, I need to get rid of this 9 and get rid of the 6. I have a plus 6, so the way I get rid of a plus 6 by doing minus 6 on both sides. This will be canceled here. This is going to give me negative 6 is equal to a times 9. In order for me to get rid of this 9, since a times 9, I must do the opposite and divide. That cancels, and I know that a is going to be equal to negative 6 over 9. You could leave it like this, or you could simplify to negative 2/3, but that is my a value. So I've sketched the scenario, but I still need to write the equation in full. Once you find that a value, you still need to plug it back in. So my final answer is going to be y is equal to negative 2 over 3, writing my a value instead of a, times x minus 3 squared plus 6. That is my final answer. Number 4 says, given the parent function of line 1, this is written on your sheet, I'll write here, this is going to be my line 1. What's the equation for line 2? Line 2 starting here. So the big difference and the big key for understanding this problem is looking at where the parent function starts. Now, in this case, we're using the word start to say where the vertex is, or what the transformation is from 0, 0. So this line goes through 0, 0, as we know most parent functions do. But now we no longer go through 0, 0 for line 2. We go through, what value is that? That's going to be negative 3, negative 2. So we're going to call this -3, -2. And what I need to recognize is that this is my HK value for my line. And we know from our x squared function that this equation is going to be of the form a x minus h to the third power plus k. All our parent functions and then our transformations follow the same pattern. So we're going to take what we know about our hk values from our quadratic in order to help us here. So in this case, I know that my values are going to be, let's see, a x minus h to the third plus k. And my hk is going to be -3, -2. That's going to be my h, that's going to be my k. So I'm going to plug that in, and that's going to be a x minus -3 to the third plus -2. And of course, once we deal the negatives, that becomes x plus 3 to the third minus 2 is my vertex form. I look at my a to make sure what my a value is. So normally I go over 1, up 1. Let's see if that's true. So I go from -3 to -2. That's over 1. And then I go up 1. My a value is still going to be equal to 1. And this is my equation. And then finally for step 5 tells us for each of the following equations, describe how the graph will transform from the parent function. So we're going to look at our parent function. We know that our parent function is supposed to be, for part A, just square root of x. So I'm going to circle all the parts that are different from square root of x. Parent function did not have this negative. Parent function did not have this +2. This parent function did not have a -4. So I've identified the 3 different components, and now I'm going to describe what each of those components do. So this negative is going to flip or reflect the graph over the x-axis. So in other words, we're going to be going from this equation, and instead now our equation, or excuse me, our graph is going to look like this. We're flipping it upside down. That is what's going to happen here. This +2, if we remember our hk value, it should be a square root of x minus h plus k. I know my h value is horizontal shift. This is going to be 2 to the left or right. But remember our h rule, whatever our h value is, we must do the opposite. So I have a +2. That means I'm going to go, instead of 2 to the positive, I must do a negative shift. So it's going to be 2 to the left in the negative direction, because that's just the rule for my h. I must do the opposite sign of whatever's given to do. So even though this is a +2, this is a -2 shift for x. So that's going to be a shift to 2 to the left. -4, k is straightforward. K is my vertical. This is going to be 4 units down. Okay? And that's what I'm asking for. Finally, for part B, I know my parent function is 1 over x. I look at all the parts that are different. There's no negative, so I don't have to worry about that. I do have a -2 and a -3. This -2 is my h value because it's directly next to my x. And once again, I need to do the opposite sign. So in this case, this is going to be 2 to the right. And finally, this is going to be my k value. And this is going to be 3 down is going to be the shift that's coming from here. And those are all the answers for our sample questions for our Unit 2 study guide. So, happy studying. Please make sure we understand where each of these problems and where each of these answers came from. and I wish you luck. I'm sure that we're going to do great. Take care.